Hi there everybody, today we are going to be looking at similar shapes. Well, what are similar shapes? Well, similar shapes are effectively two shapes which are the same but different sizes. So one is going to be an enlargement essentially of another, and that's really what we're going to focus on. The important part of this also is that angles in similar shapes are always the same. So they never change. So that's something to bear in mind, and obviously sometimes that comes up in assessments. So just kind of look out for that one. All right. So the best thing to do is look at a couple of examples. So you're going to start off with a particular shape, and then you're going to be given another shape which is arguably bigger, or it could be the other way around, smaller. And then you're going to be essentially told, in most cases, that these two shapes are similar. And what you are looking for is really to try and identify what the similarities are. Now, often it is all about the numbers. So you can see from here on this one, you've got the 2, and then you've got the 4. And then you've got the 5 and the 10. So you can see, hopefully, from here that the 2 has been increased by a multiple of 4, and it is always a multiple or a scale factor. And then the 5 has been multiplied by 2 also to get to 10. So the scale factor of between these two shapes is a scale factor of 2. They've both been increased by 2, all right? Or they're in the ratio of 1 to 2, 1 to 2, all right? So that's another way of kind of thinking about it. But essentially, these two are similar. They've both been multiplied by 2. So in problems, in questions, you're going to be told that, and of course, you're going to be using the fact that they are similar to find missing lengths of sides in most cases. Okay, so like I said, this one has a scale factor of 2. So looking at this particular one, it asks you to calculate the missing side of these similar shapes. So we're trying to identify what the ratios are, or what the kind of scale factor is. So we're focused on the 2 which are we know which is the bottom size here. So we've got the 2 here, and we've got the 6 there, and you can see that's increased by a multiple or a scale factor of 3. So in terms of identifying the missing side, which is this one over here, we're concentrating on this and thinking about what's the scale factor. Well, the scale factor is 3, so therefore we are going to multiply the 4 by the 3, which is going to give us 12. All right, so you can see that kind of written down. So a good way of working out what the scale factor is you take the larger one and divide it by the smaller one, and that's going to give us the scale factor there. All right, if you did it the other way around, if this was smaller and this was bigger, then you could do that one, but then it'd be a third. All right, so of course the number's then going to get smaller. All right, so like I said, the new side is 4 times the scale factor, which is in this case going to be 12. All right, so that's the scale factor of what we call a similar shape in 2 dimensions. All right, so we may kind of come across this in area and volume as well. Okay, so we need to know how to kind of deal with similar shapes when it's area and volume. So we're going to focus on that now as well. So let's kind of look at a similar example. But what you've got to bear in mind in this case is the area has not just had one dimension changed, it's had 2 dimensions changed. So as a result of that, the area of a similar shape is enlarged by the scale factor, which we just saw for one side, but also the other scale factor on the other side. So essentially the scale factor squared, which is what we're kind of saying over here. So let's look at an example here. So we can see you've got the same shape as we had before, so 2 centimetres by 5 centimetres of a rectangle, and therefore the area is 2 times 5, which is 10 centimetres squared. And then we've got an enlarged shape. In this case, you can see it's enlarged by a scale factor of 6 divided by 2, which is 3. And similarly, 15 divided by 5, which is also 3, which of course it needs to be the same. So the scale factor in this case is 3. But what you'll notice is the area of this one, 2 times 5 is 10. And then when we do 6 times 15, well, that's going to give us 90. So you can see that the scale factor of the area isn't just times by 3, which is the same for the sides. This is times by 9, which is 3 squared. All right, so that's what we're thinking of. So it's going to be 3 squared. So the scale factor is 9. So that's something to watch out for when we're thinking about area of similar shapes. All right, so given an example over here. So like the one we had previously, we're looking for the scale factor first of all. Well, we can see we've got 2 and we've got an 8. So this has been multiplied by 4. And when we're thinking about calculate the area of the shape, which is what the question is, well, a good way to start is we could figure out what this side is, or we could figure out what the area of this is. All right, so there's 2 ways you could do it. And then once you've got those dimensions, you could work out the area of base times height and half it. Or I'd work out the area of this one, base times height and half it, and then times it by the scale factor squared. Okay, I hope that made a little bit of sense, but let's see kind of what we've done now. So we're looking at the scale factor of here, so which is going to be 4. All right. So using the scale factor of 4, well, we're thinking about the area of the first shape, so this is the way we're going to do it this time around. So the area of this one is 5 times 2, which is 10, and half it, okay, which is what we've got over here. Half base times height, 5 centimetres squared. And because we have the scale factor of 4 for the sides, the area must be multiplied by 16, which is of course 4 squared. So the area of the new shape is 5 times 4 squared, which is 5 times 16, which is going to give us 80 centimetres squared. And if we were to work out the length of this side, or if we were to do that, then this would be multiplied by 4, which would give us 20, and then it would be 20 times 8 and half it, which would give us 80 centimetres squared. So there's 2 ways you can approach that particular question, but in this case we've just gone straight for the area of the first shape, and then use the fact that we know that the scale factor squared is what we're going to need to work out the area of this one. All right. So there's 2 ways you can approach that particular question. All right. Hope that makes sense. So finally, we're going to look at volume. Volume is the next step, obviously, but volume is calculated by using the 3 dimensions of a particular shape. So when we're looking at similar shapes in 3 dimensions with volume, and then we're going to look at the side, obviously find out what the scale factor of one particular side is, and then we're going to basically cube it for the volume. All right, so that's the kind of the difference with this one. All right, so like last time, is that depending on the question, is we might not be given lots of information, we might not be given all the dimensions to kind of work with, but we're certainly going to be given enough information to calculate what we need to do, and you will be required to understand that the volume will be cubed from similar shapes. Okay, so this will make more sense when I go through the example. So here you can see we've been given only one side, which is 2 centimetres, and the volume of 24. All right, so we don't know the other 2 dimensions, but of course they're going to assume that you don't need them. And then you are going to be told that this shape is similar. Okay, and that's quite important because we don't have all of the dimensions, but what we do have is we've got a side which is 2, we can see that one there, and the other side which is 4. So we can see that it's increased by a scale factor of 2. So therefore we are looking at the volume of 24, which will increase by a scale factor of 2 cubed. Okay, so 24 times 2 cubed, which is 8, will give us 192. All right, so the length of the side has been multiplied by 2, and the scale factor is therefore 2 cubed, which is 8, which you hopefully can kind of see. All right, so that's what you've got to kind of focus on, is that idea of identifying the scale factor and then ensuring you're aware that it's volume that's changed, and therefore increased by 2 cubed. All right, so looking at this particular example, it asks us to calculate the volume of the similar shape. So we can see over here we've got 2 and the 6. So 6 divided by 2 is 3. So our scale factor is going to be 3 in this particular case. So it's increased by a scale factor of 3. So we now need to calculate the volume. Now we don't have any other dimensions to work with other than the volume given in the small shape. So we have to use this fact to calculate the volume of this newer, bigger shape here. All right, so we're going to do 5, and we're going to multiply it by the scale factor cubed, which you can see written over here. So 5 times 3 cubed, which is of course 5 times 9, which is, no it's not, it's 5 times 27, I apologise, I should know one of my calculations better. So 5 times 27 is 135 centimetres cubed, okay, and that's volume. Now of course in exams you may get a hybrid of these kind of calculations. They might give you an area and a volume, and obviously the more challenging the question, you would argue it's probably going to be worth more marks. But certainly this idea of understanding volume and area is quite important, because they won't necessarily give you every single piece of dimension within the shapes. That idea of it being similar should be enough for you to kind of work with with any particular question. Okay, so please do get onto the website maths-school.co.uk and get a bit of practice on some of these questions. Thanks for listening.